how can you tell if a redox reaction occurred? How can you tell if a given reaction is a redox reaction? If it's a redox reaction, the oxidation numbers must have changed. If the oxidation numbers didn't change, it wasn't a redox reaction. What I want to remind you of is that if an atom's oxidation number increases, it got oxidized, and if the oxidation number decreases, it got reduced. Hopefully that's intuitive. Otherwise, it wouldn't be called the oxidation number if oxidizing it didn't increase that number. Huh? So let's check it out. Assign oxidation numbers to these and tell me if there's been a redox reaction. Do you remember the rules for assigning oxidation numbers? Elements are always 0. This is just metallic copper, just the element. Oxidation number 0. Same with silver, just an element, 0. Hydrogen's always +1, but that's not an issue here. Oxygen's always -2. So this oxygen's probably -2, and this oxygen's probably -2. You have to assign the other oxidation numbers just so that the total charge on the molecule, in this case 0, is the sum of the oxidation numbers of all the atoms inside of it. We got a charge of -2 here, and we got 2 silvers that can help to counteract it. So each of those silvers needs a charge of +1. Get it? 2 +1s cancel out a -2. Yeah. Here we got 1 copper and 1 oxygen. That oxygen has a charge of -2. This one needs a charge of +2 to counteract it. Check out what happened here. We have copper, whose oxidation number went from 0 to +2. Its oxidation number increased and it was oxidized. One thing I want to point out is that for the oxidation number to rise, it has to lose electrons. Oxidation is a loss of electrons, and so as you lose negative charges, your charge increases. Anyways, silver, you'll notice, went from +1 down to 0. It decreased, and so silver is the thing that was reduced. And if you went from a positive down to 0, you must have added some negatives or gained electrons. A typical question you'll see in this kind of thing is assign oxidation numbers to determine if a redox reaction has occurred. What was oxidized and what was reduced? Check out how fast this can go. That's an element, oxidation number 0. That's an element, oxidation number 0. No hydrogens, no oxygens. Assign the rest of the oxidation numbers. Iodine likes a charge of -1 and potassium likes a charge of +1. Look it up. Those are the valences. Potassium likes a charge of +1. Chlorine likes a charge of -1. Those are also the valences. So, any oxidation numbers change here? Chlorine went from 0 to -1. So oxidation numbers did change. So there was a redox reaction. Chlorine went from 0 to -1. That's a decrease. Chlorine was reduced. What else changed? Iodine, it looks like, went from -1 to 0. That's an increase. So this must have been oxidized. Pretty easy. Let's assign oxidation numbers here. No elements, no hydrogen, no oxygen. Well, let's just see what kind of charges these atoms want. Chlorine usually wants -1 and sodium wants +1. Fluorine wants -1. Silver can have +1. Fluorine usually wants -1. Sodium usually wants +1. Chlorine usually wants -1. Silver is okay with +1. These are all the valences of these atoms, by the way, in case you don't know where I'm getting these numbers. Did any of the oxidation numbers change? No. None of the oxidation numbers changed. No redox reaction happened here. Nothing was oxidized, nothing was reduced. This is just a regular double displacement reaction anyways. Shouldn't be surprising. We're going to do one more. I realize I skipped C, but we're all grown-ups here. You can suck that one up. What are the oxidation numbers here? That's an element, oxidation number 0. That's an element, oxidation number 0. No hydrogens, no oxygens. Chlorine wants to charge a -1 usually. Sodium likes to charge a +1, so that works out. Oh, sodium went from +1 to 0. That's a decrease in oxidation number, going from 1 down to 0. A decrease in oxidation number means the sodium was reduced. The chlorine went from -1 to 0. The chlorine's oxidation number increased. It was oxidized. There was a redox reaction. Sodium was reduced, chlorine was oxidized. Figuring out if a redox reaction occurred is a piece of cake if you can assign oxidation numbers efficiently. Best of luck.